And hello everyone, welcome back to another nim tutorial. In this tutorial, we'll be taking a look at tables in nim. Now, a table is a very powerful data structure in nim, similar to the dictionary or the object in Python and JavaScript. Let's get started. Let's import std tables, and this will allow us to use tables. Let's create a user1, make them equal to, and we get like this, username, and it should be a string, and their username can be Nick, and their password can be this. Alright, so imagine this is a website where users can sign up, and the user can enter their username and password to log in. Then here we can just say .toTable, and this will create a table for us. Now here we can just, if we wanted to, echo out user1 and see how it looks. So here we have password and then username. Take note that these are not ordered. So if you put username first, it might not be first, like in this case it is second. Password as well. They are not ordered, and this is implemented as that for performance reasons. Because when they're not ordered, with most data structures, if they're not ordered, it's faster. Now we can easily access an item in here by just going brackets and then in quotes putting the key, and this is the value. So if we put the key in here, it will return us the value associated with this key. So if we were to run this, we will get Nick, as you can see there. You can also change what is saved inside of here. So if we were to say instead of Nick, we would say Mike here. So we're getting it, it will display Nick for us. Then we're changing this set username here to Mike. Then we're displaying it again. So this one will be Mike and the top one will be Nick. So it's Nick, change it to Mike, and then Mike. You can also use this to add new values such as age, and let's go 99. And we of course display the age here. Save this, and then my bad, this should be a string because it can only be the string or whatever type you put here, and then another specific type. You cannot have a string number and then a string. These should always be the same type, these as well. So now if we were to run that, we will get 99. So you can add more items here. If we were to remove that, we will see age is displayed in here. So age, password, username. Now let's say you want this to stay in the order you set it as. Username and password, these two should be first username, then password. Not like this where it's password, then username, and sometimes age is put before them and whatnot. To make sure your table stays in the order you create it in, you can say to ordered table. It's the same as a normal table with the difference that it is ordered. So if we were to run this, we'll get username, password, because that's the order we're giving them here, and then age, because that one has been added last, so it will appear last. So this is the same as the normal table we just took a look at. However, the primary difference here is that it will always stay ordered. This is of course at the cost of performance. If you do not care too much about performance at the moment of coding, then you don't need to worry about keeping it ordered. But if you need to debug or anything like that, then ordered tables can also be useful. You can also check if one of these has a specific key, such as username. And of course, if you just go .has key, username, and it will check if they have a key. If this key does exist, and we run this, it will return true because username does exist in here. If I were to say usernames, this key does not exist in there because there's username, not usernames, then we will get false. And then finally, let's say we create this username field here again. Now, instead of saying to ordered table, we say to count table. Now, what's going to happen here is we're going to count the amount of times a key and value is inside of this table. So if I were to display user1 here, we will get password 1, username Nick 2, because username : Nick is found 2 times inside of this table. So it will have a 2 here. Whilst password with the key of passwd, these only appear once, so it will have a 1 here. Now, one thing I want to show you is, let's create a couple of tables. We can create friends, and let's say we want to create an empty table. An easy way we can do that is init table, and then we say what the key should be. The key should be a string, and we say what the value should be, which should be an int. And then we just call it as a function. Now this is a table where we have a string and an integer, where the string is the key and the integer is the value. We can also do another one called letters, and we can say init count table, and we just say char. This will create an empty count table for us, which has the values of char in here, meaning count the characters. And let's just create a here just to show an example of init order table. But since it is the same as an init table, just ordered, I'm not going to spend too much time on this. String, because order table is the same as init table here. So not much of a difference except that it's ordered. So I'm not going to spend a lot of time here. Okay, so now we have 3 variables. All of them are tables. Now you can of course add values here, as we said before, by just going friends. And let's say Jack. Now the key has to be a string here. That is what we're doing here. The key has to be a string. The value has to be an integer. So here I could say 90. So it could be the Jack is 90 years old. And here we can go Mike is 59 years old. Now if we were to echo friends, we'll see it's a normal table. But the difference is now we have numbers here as the values instead of strings. And the key could also be an integer if you want. So int, and here we could maybe go 1, 2. We run this, then 2 will be 59 and 1 would be 90. So you could change this to a different type if you want to. I will keep it a string for now. Let's assign letters a couple of values. So letters is equal to count table. So this will create a count table from this here. Now it does say open array A, but what we can put in here is just a normal string, and it will convert that string into an array of characters for us. So hello world, this is a great place to be. And now we just display letters. So here we can see there's 1 D in this whole string. There is 3 O's in this whole string. There is 8 spaces in this whole string. And it basically counted all of the characters for us, which can be very useful in some scenarios. Take note, a capital letter is not the same as a lowercase letter. So a capital letter H, a capital letter W, and a capital letter T is not the same as their lowercase counterparts. Now you can also clear a table by just going letters, and this also works with normal tables and ordered tables. .clear, and if you echo it again, then now it will return an empty table right here. So you use .clear to make a table go empty again. You can also compare tables with each other. In this case, we're just going to say letters and friends and then compare them to each other. Now these will both return true. So it will check if they're the same, but take note that you cannot compare two different types. If I were to say letters equals to friends, it will not allow us, because a friends is of type table, whilst letters is of type count table. They are different types. It is like comparing an integer to a string. You cannot do that because they are not the same type. And if we were to put a here, it will still give us an issue, because an ordered table is not the same as a table. They are defined as two different types. Now let's say we want to, let's just echo letters here. We want to increase the number of spaces here. So currently it's 8. To increase that, we can just say .inc and we go space. And this does not echo, so let's just do this. So we'll increase it by 3 and then we'll print it out again. So now spaces is 11. So we can use the value.inc or the variable.inc to increase the amount in a count table. You can also return the one with the most amount of value, so .largest. That would be spaces, which I believe has 8, so it has the most. And also smallest. That will do the opposite and return those with the least amount of values. So here we have space with 8 and then we have D with 1. Even though there are multiple with 1 such as H here, it will not return H as well. It will return the first one it finds with the lowest value in it. Space, the same with largest. It will find the first one with the largest value and it will return that. In this case, space has 8, not 11, because we removed those extra .inc lines. So it's not 11, but actually 8 here. And it will return the largest and the smallest. You can also check if letters contains, and let's say contains H, which we know is true. H, and let's try again with Z. So the first one should be true and the second one should be false. Correct. Because the first one does include an H. If we were to just print out letters here, then you'll notice we do not have a Z in here at all, but we do have an H. So if this H key exists inside of this table, it will return true. You could also go letters.delete, and we can just delete, let's say, spaces. Spaces is here. As you can see, there's 8 of it. So if we delete space, then there will no longer be a space in here. Another fun fact is if we were to say variable b, which is of type integer, and echo out letters.pop, and let's choose I. So right here, I, which is 2. So we choose I, and take note I'm using single quotes, not double quotes. It's always important to know the difference. A double quote is for a string, a single quote is for a char. A char is a single letter or a digit like this, whilst a string is basically a full piece of text. And let's just say B. Let's also echo out B. So this does the same as letters.delete, but it makes B equal to the value that is being deleted here. So I is 2. If we were to run this, then B would be 2, and pop will return true because it could delete that I value and store it in B. So now B is the value of I, but I, if we echo out letters here, doesn't exist inside this table anymore. So you'll notice there's no I here anymore. We can also echo out letters.get or default, and it will default, let's just go here, default Z. So it will get the item. If it does not exist, it will return the default type, that would be an integer and default to 0 for this value. So in this case, if it will try and get the Z, if this Z does not exist, it will return 0. So if we run this, and take note, a lot of this I'm just doing with this count table, but you can do a lot of these with their normal ones as well. Like let's say friends, get or default, and let's go Lucy. And this should be a string, of course. So as you can see, there's 0 because Z does not exist. If we were to change this to capital T, and we just run this, so this will be 0. So Lucy would be 0 because it is a string and then the value is an integer. So Lucy would be 0. And in here, T would be 1 because it could get 1. So a lot of these functions I'm showing you works on more than just the count table. Take note of that. And you remember how we could go has a key, and let's say has key T, which would return true. We could also go has key or put, and it will try and get that key. If it does not exist, we can put a value there. So let's go Z and put 10 there. And my bad, this has key or put does not work with a count table, so we will need to go friends here. And here we just need to go Nick, and there's 10. Okay, so this will basically work the same. We can actually just put friends here, and let's go Nick. So there we go. So checking if friends has the key Nick. This will be false, of course, because it does not. And then here we check if it has the key. If it does not, we put this value here. So let's actually then echo out friends so you can see what's happening. If we run this, we get false. False because it did not have it, and then Nick 10. If we were to copy and paste this again, let's go like this, and let's make this 20 just so we can see what happens. Then we'll get false, false, true, and you'll notice this value did not go to 20 because now Nick already exists in here because we have put the key inside of the table and we gave it a value of 10. So if it does not exist, give it this value as a default. We can also get the length of a table by using len. So len, and just get the length of the table, which is 2 in this case, yep, because there's only 2 keys here. We can also go here and say more letters is equal to 2 count table, and let's just go. My name is Steve and I am very cool. There we go. Then what we can do is we can say letters.merge more letters. Now letters would have all of the values inside of more letters. Let me run this. You'll notice now spaces is equal to 16. Our exclamation marks has been increased to 3. Our these is now 2 because it now includes all of the letters in more letters as well. So you can use this to merge 2 tables together. You can also sort. So let's say here we go letters.sort, and this will sort this letter count table, but it will sort it in descending order with the one with the highest value. So spaces would be first because it has the highest value. So there we go. 16, 8, 6, 5, 5, 3, 3, 3, 3, 3, 2, 2, 2, and so on. We can also go through each and every key here by going for key in letters.keys. And we can echo out the key. So it's just a normal for loop, but for every key, which is this value here, this is the key. This here, that space is a key, that E is a key, that A is a key. So if we run this, it will echo out all of the keys for us. So there we go. This can also be done with the values. So value here, and we say, we go here, values, and now we will get the values instead of the keys. So as you can see, now we get the numbers, so the amounts. If you want both, you can go pairs, and then ask for the key, comma, value. So the key and the value. Then we can just go key, and here we just say, and there we go. And I'm not in the mood, so I'm just going to say import str format. There we go. And here we can just format this into a normal string. And here we go. Now if we were to run this, we'll get key and then the value, key and then its value, key and then its value. And that is the basics on tables in Nim. There's a lot more you can do. However, I think this is more than enough for us at the moment to handle. Thank you for watching. I hope you all enjoyed. Please like and subscribe, and I'll see you all again in the next nim tutorial.